so that anyone who's absent can use that to catch up. Oh, Raina came in. Let me mark that down. Alrighty. So the last thing that we're looking at today, you'll want to have your notes and you'll want to have a calculator nearby, are still looking at exponential equations, but these are two cases that are going to require factoring. So, we factor a lot, so hopefully that's not too much of a problem for us. So you'll notice on number 8, that we have exponents on both sides. We saw one like this when we looked at exponentials, but we were able to rewrite both sides using the same base. Here we can't. 5's not a power of 4, 4's not a power of 5. So that means that we're going to have to use logs. So the first step, just like we've done before, is we're going to take the natural log of both sides, and you can just kind of squeeze it in there. Don't forget that the exponents on each side are a single exponent, so we need to maintain the fact that they're a single quantity by using parentheses whenever we work down there, okay? So now the exponents we get to bring out to the front of the natural log. So here's what we have. X minus 2 times the natural log of 5 equals 2x plus 3 times the natural log of 4. Okay. Oh, I also let me open up the chat in case anybody posts any questions. Okay. I've got the chat open on the side of my screen now. So feel free to type anything in, or as always, just turn your mic on and ask a question. Okay. So we are trying to solve for x. We've gotten them out of the exponents, so that's good. But we have them, they're still stuck in parentheses. And since I have x's on both sides, my only option here is to distribute out those natural logs so that we can move all the x terms to one side and all the constant terms to the other. So just remember, natural log of any number is still just a constant. So when I distribute there, I get x times the natural log of 5 minus 2 times the natural log of 5. Same thing on this side. I'm going to distribute the natural log of 4. So I get 2x natural log 4 plus 3 natural log. Okay. Anybody have any questions so far? Bring your exponents down, distribute out the natural log. Now, remember our goal is we need all the x terms on one side and all of the log terms that are just constants on the other side. So here's where we have, this is just a constant because it's all numbers, and this is just a constant because it's all numbers. We can see where our variables are is here and here. So I'm going to subtract the 2x natural log 4 to the left, and I'm going to add the 2 natural log 5 to the right. So what happens there is we now have x natural log 5 minus 2x natural log 4. That's because I subtracted this one to take it to the other side. And then I'm going to have equal to 3 natural log 4. That's what I had on the right. And then I'm going to add this guy to the other side. So now I have plus natural log 5. All we're doing there is rearranging, because now both of our x's are on the same side. Now, the weird thing about what we have here now, and we saw this, we've seen this several times throughout the year. This is where, like, when you were solving a formula for a variable, those are not like terms, so we can't combine them. But since they both have the x in common, we can factor the x out. It's a GCF, a common factor between the two. So we're left with natural log 5 minus 2 natural log 4 equals 3 natural log 4 plus 2 natural log 5. Now you notice, whoops, I forget, you can't see that when I scroll. What we've got here is all a constant. Even though we haven't put that in our calculator, we can get a single value for that. But now all we need to do to get rid of it, since it's just a constant, is just divide both sides by natural log 5 minus 2 natural log 4. Natural log 5 minus 2 natural log 4. So remember, in my math lab, you're going to give the answer both in terms of the natural log and as a decimal, typically. So in terms of the natural log, x is equal to this whole mess. 3 natural log 4 plus 2 natural log 5 all over natural log 5 minus 2 natural log 4. That's our answer, all in terms of the natural log. Does anybody have any questions on how we got there? Bring your exponents down, distribute, rearrange, factor out the x, and then you can divide by whatever's left. It's one of those things that I think because of all the ln's, it looks uglier than it is. If you were just doing this with plain numbers, I think you'd have no problem with this because we've done this before. Now, here's what I want you to practice. So grab your calculators. I want you to practice inputting this expression to your calculator. Now, if you have one of the newer ones and you can set up the fraction on your screen, great. If you have one of the older ones like me, you're going to need several sets of parentheses. So you're first going to need parentheses around the entire numerator and the entire denominator before you divide. The second place you're going to need parentheses is to close your logs every time. So you're going to need all those parentheses when you type it. So whatever calculator you're using, again, it doesn't have to be a graphing calculator. Will you go ahead and take a moment to try and type that in with me so you can see if you are typing it correctly? So once you've got it typed in, if you don't have one of the fancy screen ones, then you should have parentheses, 3 natural log, parentheses 4 parentheses, plus 2 natural log, parentheses 5 parentheses, and then another parentheses to end the numerator. Then you hit divide, then you start parentheses again, and you have to do the same thing in the denominator, and I get approximately negative 6.342. Hopefully that's what we are all getting. Okay. Does anybody have any questions here? Okay. I would like for you to take a moment to try number 9, or at least to get started on that. I'm going to give you a little bit of a head start before I start working on it. Okay, now that you've tried one on your own, does anybody have any questions on this process? Any of the lines here where you got lost? You can turn on your mic or you can type it in the chat. Okay, so this one, both of these examples require factoring in the sense that you have to factor out the x as a GCF. So GCF, that's like the best kind of factoring. You just pull it out. Now, these last two examples require factoring the way that we factor quadratics, because these are quadratic in form. They're not quadratic equations because they're exponential equations, but see if you can notice what we're doing here. Look at the exponents. So I have e to the 2x. Remember we said any even exponent is a square. And then we have x, and then we have a constant. The reason this is in quadratic form is because this is essentially e to the x squared. Remember, we multiply powers, plus 4 times e to the x, and then plus 3. This is our, of the form au squared plus bu plus c. And in this case, the u, which represents the algebraic quantity here, is e to the x. So sometimes it's much easier. This is something we do in calculus all the time. We'll see this come up when we look at the trig. When you see something that's really ugly like this, e to the 2x minus 4e to the x, we use this technique called u substitution. Why do we use u? Probably because it's not a variable that gets used very often. But u substitution means we're going to let u equal the ugly piece of the expression or the equation. That allows us to write it in a simpler form that is more friendly to work with. So in this case, what I might do is let u equal e to the x, because that's what's getting squared and multiplied inside there. And if that's the case for this particular function, then what we have is u squared, because again, that's e to the x squared, minus 4u, because that's e to the x, plus 3 equals 0. That's an equation that we can factor. This is going to be u minus 1 times u minus 3 equals 0. And that's pretty easy for us to solve. We know that u has to equal 1 or u has to equal 3. That's great. We found out what u is. But remember, u is not what we started with. E to the x is what we started with. So now we come back and we replace our u's with what they were originally. Now we need to solve the equation e to the x equals 1 and e to the x equals 3. Those are much simpler exponential equations than the one that we originally started with. And so this is why that u substitution, it kind of helps you get past the ugly part, and then you get to something simpler. So here, we'll take the natural log of both sides, natural log. So we get x is equal to the natural log of 1. Remember, the natural log or any log of 1 is always 0. So there's one solution. And on this side, we get x is equal to the natural log of 3, which we would have to put into our calculator. And that is approximately, you could leave it as natural log of 3. That answer is great. Otherwise, it comes out to 1.099. Okay. Anytime you see this e to the 2x like that, you just need to think of it this way. That's e to the x squared. You can always rearrange a multiplication power into like levels of exponents. So that's always how you want to think of it. Now, if you don't like putting in the u's and you would rather factor it with the e to the x's in there, that's fine. This is just a couple of different options of how to do it. So does anyone have any questions on what we looked at there? So for number 11, what I would like for you to do first is see if you can rewrite that in terms of u. So same thing, you always got to define u. You can't just throw a new variable in there without saying what it is. So if you're going to use this u substitution, you have to let me know what u is representing. That's going to be worth a point. You got to have that down. But so if we let u equal e to the x, see if you can rewrite that equation in its more friendly form so it looks like a quadratic. So this is what it should look like. U squared, because that's e to the x squared, minus 8u, 8 times e to the x, plus 7 equals 0. So now factor and solve that, and then see if you can finish this the rest of the way. Okay, so here's what I come up with. So you get u, nope, this is definitely wrong. This should be minus 7 and minus 1, not minus 8. That makes no sense. So this should be equal to 1. So e to the x is equal to 1, which means e is equal to 0 again, just like on the other one. Now, a quick side note. What if you got something like e to the x equals -2? Well, you'd take the natural log of both sides and you'd get x is equal to the natural log of -2. There is no solution that comes from this because of what we know about the domain. You can't log a negative. So if that was the case, you would either not get a solution at all, or maybe you only get the other solution or whatever. Just remember, you can't log a negative. So if that comes up in these types of equations, then that one just doesn't count. Okay, I'm going to stop sharing here. So does anybody have any questions before we wrap up for today? We're done a little bit early, but